see another property, time reversal of a sequence. Time reversal of capital N point sequence x of n is obtained by wrapping sequence x of n around a circle in clockwise direction, which is denoted as x of minus n modulo n is equal to x of n minus n, where value of n is ranging from 0 to capital N minus 1. So figure represents we are arranging sequence x of n in clockwise direction. So x of 0, x of 1, x of 2, x of 3, we have wrapped these values around a circle in clockwise direction. So time reversal property of DFT is given as if DFT of x of n is x of k, then DFT of x of minus n modulo n will be DFT of x of n minus n, which is given as x of minus k capital N is equal to x of n minus k. Next property is circular frequency shift. Circular frequency shift of DFT is given as if DFT of x of n is equal to x of k, then DFT of x of n multiplied by e raised to j 2 pi ln by n is equal to x of k minus l modulo n. So in previous thing we have seen circular time shift where we are multiplying e raised to or exponential term in frequency domain. Now we have to consider x of k minus l modulo n, that is we are shifting in frequency domain. Next property is of complex conjugate property. If DFT of x of n is equal to x of k, then DFT of x conjugate n is equal to x conjugate n minus k, which is equal to x conjugate of minus k modulo n. For example, given x of n is of length 14, then for n equal to 14, x of 8 will be equal to x conjugate of 14 minus 8, which is equal to x conjugate of 6. Now just we'll see another example. First 5-point DFT of real valued sequence are as 0.25, 0.125 minus j 0.3018, 0, 0.125 minus j 0.0518, 0. Determine remaining 3 points. Now actually what they have said, they have calculated 8-point DFT of a sequence, means in answer there should be 8 values. Out of these 8 values they have given only 5 values, that is they have given x of 0, 1, 2, 3 and 4. We have to calculate x of 5, 6 and 7, and to calculate these values we have to use property of complex conjugate. So we have x of k is equal to x conjugate of n minus k. We have given sequence x of k having 5 values. So x of 5 is equal to x conjugate 8 minus 5 using complex conjugate property, that is equal to x conjugate 3. So what is x of 3? We have to take its conjugate. So as I discussed earlier, what is complex conjugate of any value? We have to just change sign of imaginary term. So x of 5 is equal to x conjugate of 3, that is equal to 0.125 plus j 0.0518. X of 6 equal to x conjugate 8 minus 6, that is equal to x conjugate of 2, that is equal to 0. X of 7 is equal to x conjugate 8 minus 7, that is equal to x conjugate 1, which is equal to 0.125 plus j 0.3018. What we did, we just changed sign of imaginary term. So finally x of k is given as 0.25, 0.125 minus j 0.3018, 0, 0.125 minus j 0.0518, 0, 0.125 plus j 0.0518, 0, 0.125 plus j 0.3018. Next property, multiplication of two sequences. If DFT x1 of n is x1 of k, if DFT of x2 of n is x2 of k, then DFT of multiplication of two sequences x1 of n into x2 of n is given as 1 by capital N in bracket x1 of k circularly convolved with x2 of k, where n surrounded by circle represent operation of circular convolution. Next property is the Parseval's theorem. If DFT x of n is equal to x of k and DFT of y of n is y of k, then by Parseval's theorem summation n 0 to n minus 1 x of n into y conjugate n is equal to 1 by n summation k 0 to n minus 1 x of k into y conjugate k. Last property, circular convolution. If DFT of x1 of n is x1k, if DFT of x2 of n is x2 of k, then DFT of circularly convolved time domain sequences, that is DFT of x1 of n circularly convolved with x2 of n is equal to x1 of k multiplied by x2 of k. Means what statement we can do here? Circular convolution in a time domain is nothing but multiplication in frequency domain. So where n surrounded by circle is known as circular convolution of sequence.